Hi everyone, so today we will go through the third topic of testing and measurement class. We will go through reliability basically, and these notes are collected from the slides both and some stuff that I added to these notes, the slides as well. So yeah, hopefully they will help you to understand the topic better. So what leads to variability in test scores? And we have a little table here. So either they can be like a lasting effect. Wait, I need a prettier color. And like someone think that doesn't look like them. So okay, that's nice. So something that is lasting, or it could be like temporary or time sampling error. It could be like a general, like it could include the entire test, or it could be like specific about specific items. Like maybe you will kind of be familiar about specific items, but it wouldn't be like the entire test, versus it could be general, like just about the entire test. So lasting effects, the one that we want is the true score, obviously. So we want the true scores, the traits, but also another lasting effect could be like knowledge about specific questions. Like for example, when I take autobiographical like tests and everything, like I know that when I talk very detailed about like my autobiographical memories, that means that I have a very developed autobiographical memory. So because I know this, when I just like when I attend an experiment or whatever, what I do is I explain things very detailed, because I know that that's a good thing to have. So my knowledge is kind of interfering with maybe what I would have done if I did not know that this is a good thing to have. So that may be one factor that is affecting the questions, but it's more like general, I guess. It's more in the general, but yeah. Question representativeness, also another thing that affects. Maybe the individual, they couldn't understand the meaning of like certain like sentences, so they answered in a way that they would have not answered if they understood what it meant. So it is called content sampling error. So when it's general and temporary, it means that time sampling error, obviously it could be from fatigue, mood, anxiety, testing conditions, etc. Or it could be like specific, which is like maybe you couldn't concentrate on like specific item, or maybe you had a recent exposure to specific content that just affected your decision making in certain items. So yeah, basically these things lead to variability in test scores. I'll delete this. Okay. So types of reliability. Firstly, we have test, retest, or stability coefficient. So test, retest, reliability, it's about like taking account of temporal inconsistencies. Like for example, you were anxious in the first time that you took the test, but you were not anxious the second time, or you were stressed, or maybe you were like tired. So we can kind of see the inconsistencies of your test result, or if they were very consistent with each other, that means that we have come to like we have gathered the information that we need, that is consistent with each other, that is not that does not have time sampling error. So it could be either short or long intervals. It just really depends on what we are trying to measure. Like if we are trying to measure mood, maybe shorter intervals will be better. But if we are trying to measure something like personality, for example, it really doesn't change like in a day or so. Maybe we can take a longer interval. So it all depends on what we are trying to measure when we are deciding for the interval in between the second, like the first and the second test. So it can cause for reactivity effect. It can cause for reactivity effect, which is like when you are aware of like the what you need to do, so you enhance like it enhances your scores because you know what you need to do. Or it can cause for carryover effects, which is like you remember, like you are taking the second test but you still remember your answers from the first test. So what it means is that you're gonna try to answer in the same ways you answered in the first time, because you are trying you're because not because you think the same way, not because you want to answer the same way, but because you answered it in a specific way the first time. So you're carrying over what you selected in the first test, which enhances reliability. It acts like you are choosing the same item over and over again, whereas you have chosen one item and you're just trying to stick to it in the second time. So it's not really the thing that we want to measure. So in the alternate or parallel forms, there are two parallel forms, in terms of content coverage, format, difficulty, and they take account of specific inconsistencies. So there's no carryover or reactivity effect because you're not taking the exam or the test for the second time. But there are issues with content sampling there, and time consuming it can be, because you need to deal with more people. And in terms of content sampling, like you need to make sure that two parallel forms are genuinely parallel to each other in terms of content, in terms of difficulty, in terms of format. So also, if you are doing alternate forms with delayed, there's also time sampling issue. Like maybe you did one in the evening, maybe you did one in the morning, maybe you did one in the Monday versus Tuesday. There's a difference maybe in Tuesdays and Mondays. Like there can be issues with time sampling, so it's important to consider that. So in terms of split half reliability, what it does is it reflects errors related to content sampling, and it's also odd versus even split is preferred in split half reliability, because we are trying to make sure that we don't cause for content sampling error. So we need to like make sure that the we are splitting in terms of like very randomly, is what I mean. So in order to check for reliability, we can use this formula basically. So which reliability to use? Obviously it depends on what we are trying to measure. So when we are measuring intelligence, we can use test and retest, because intelligence is something that really doesn't change. And we can use alternate as well. In terms of personality, we can also do test retest, because personality doesn't change that fast. Obviously personality can change, but it doesn't change very fast. So we can use like long intervals compared to mood, for example. So when we are doing a vocabulary test for third graders, we need alternate forms or split half, because vocabulary, I mean, it will get better. When we are doing test retest, it won't make any sense and we will have a very low reliability, because there will be a lot of carryover effects, there will be a lot of reactivity effects, And in geography knowledge, we also need alternate forms and split half, because geography knowledge again can have a lot of carryover or reactivity effects. So in anxiety or mood test, we can do alternate forms or test retest with very very short intervals, because anxiety and mood, our mood can change within an hour, within 2 hours, or a day, so we need very short intervals. So our fourth reliability is internal consistency reliability, and it just reflects errors due to content sampling and homogeneity of test. Like we are, I wrote this in Turkish. So we are looking how compatible test items are. This is what I wrote basically, if you don't know Turkish. So consistency across items in some test, in the same test we are looking for. So test measuring narrower construct will have higher reliability than broader construct, because with broader construct there will be a lot of other things. If a test has multiple factors, like we need to compute alpha, like we need to compute Cronbach alpha coefficient for each factor, because it will have lower reliability with multiple factors. So we need to compute Cronbach alpha coefficient for every factor. So Cronbach alpha coefficient is how each item relates to some of other items. Like we have here a formulation of how we can do it, but I think it's not really that important, but I don't know. Each item is a sample of behavior, and within the same factor, more items we have, higher alpha we are going to have. So alpha is basically the mean of all possible split half reliabilities, is what we have, what it is, what internal consistency reliability is basically. So our fifth reliability is inter-rater reliability, consistency of items provided by different observers. So in inter-rater reliability, so we use different computations. Firstly, we can use correlations between I couldn't read my own handwriting, but voters, yes, correlations between voters for continuous data, or Cohen's kappa for categorical data, like yes or no, etc. Like if the, like for example, if the participant was really behaving in an aggressive way, yes or no, maybe we are coding in a yes or no way, maybe we are coding in a 1 to 10 how aggressive that behavior was. So it's important, we can do either one of these. We can use correlations between voters for continuous data, or just categorical data, which is yes or no. So we have classical test theory and general model of reliability. This is the formulation basically. We have the observed score, and we have true score plus the error. So the errors could be negative or positive, obviously. So it could increase the true score, or it could decrease the true score, and that in return we will have our observed score. So in order to get the true score, what we need is to basically deduct error from observed score. So we have some assumptions in classical test theory. Firstly, our first assumption is the mean error is 0, and our second assumption is correlation between true score and error is 0, which means that there is no correlation, no relationship between our true score and the error. And our third variable means that correlation between errors of items is 0. So for example, if we are measuring the same item in different tests, there are no correlations between errors, because there will be errors in each test, each study, but there won't be any correlation between errors. So basically this means proportion of variance in test scores, like observed scores, that is due to variability of true scores. So like if we get an R of 0.80%, this means that true score is only 80% of observed score, which means 20% comes from random factors. So we need to account for this. Here you can see like error is observed minus true score. Here you can see some formulations. It's the same thing basically. If we have a reliability of 1, that means that all of our scores are true scores, and we have an error variance of 0. So as reliability decreases, our error variance increases, obviously, because our study is not reliable enough. So then we have generalizability theory, and it's somewhat different than classical test theory. Like for example, classical test theory claims that error is random, but generalizability theory says that error can be random or systematic. So it may be systematic. It says it may be, it may correlate with things. So the second thing about generalizability theory, I can't pronounce it very well. So systematic error can be due to human raters or testing conditions, and this is it for reliability. I hope to see you in next class, and thank you for listening, and I hope this class was helpful to you.